Okay, this is Introduction to Algebra Thinking, Algebra 1, Semester 1, Unit 1. This is the very first of the Introduction to Algebraic Thinking. We want to go over a few rules from adding and subtracting integers from pre-algebra. So let me go over a few of those. I'm trying to make sure that I'm in the Finder. You will find these in your notes. When signs are the same and you're adding and subtracting positive and negative numbers, then when the signs are the same, you add and give the answer of the same sign. When the signs are different, you subtract and give the sign of the number that is farthest from 0. Okay, so that's how you know on that. Let's do a couple practice problems. Negative 3 minus 16. Rewrite that as an addition problem if you want to see the signs being the same. It's negative 3 plus a negative 16. Signs are the same, so you simply add them and give them the same sign. That would be a negative 19. Now the next one here, 42 plus 17, just like a regular addition problem. They're both positive, so we just add them together and give them their same sign. Positive 59. Next problem. 23 minus 15. That's a negative 15 and a 23 positive. This is like what you've always done with subtraction problems. But realize that really is a negative 15. It could even be rewritten as 23 plus a negative 15. You would end up getting 8 because 23 is farther from 0. You leave it with a positive 8 answer. You don't have to put the plus. Next problem. Negative 15 and 29, they're different signs. So we would subtract them. And then you give them the sign of the larger number. So that's 14, and then 29 is, I shouldn't say larger number farther from 0. 29 is farther from 0, so we give it the positive 14. Okay. In multiplying and dividing, these are the rules you guys always remember really well. When you have signs that are the same, the answer is positive. When you have signs that are different, the answer is negative. These signs are the same, you know the answer will be positive. Go ahead and multiply those, we get 48. Signs are the same, we know the answer will be positive. Go ahead and multiply those, 147. If those are difficult for you to multiply in your head, feel free to write them down. You've got plenty of room there. The answer is negative because the signs are different, so it would be a negative 30. Answer would be negative because the signs are different. negative 45. Okay? That's just review problems for this course. Here's another one. In the fraction 2/3, 2 is the numerator, 3 is the denominator. If you have trouble remembering that, I always think of D as being down low. So the denominator's down low. Two fractions that represent the same number are called equivalent fractions. The word percent means per 100. And now let's practice a few things with these items. Okay. First one here, we're adding fractions. In order to add fractions, you have to have a lowest common denominator. Anytime you add or subtract fractions, you need a lowest common denominator. Okay? So we look at these and we say, well, 3 and 5, they'll both go into 15. I just asked students to make a big line with a 15 on the bottom. Then you have to make sure that you convert this fraction into 15 on the bottom by multiplying by 5. 3 times 5 is 15. So now take your 2 times 5 and show it on this line. 2 times 5 plus, now over here, 5 times 3 is 15, so we put a times 3 up on top. That would be a times 3. So 3 times 3. The most common error with fractions is that you will forget to convert your top number with what you've multiplied your bottom number by. So 2 times 5 is 10. 3 times 3 is 9. 10 plus 9 equals 19 over 15. For algebra purposes, where we may be plugging that back into other equations, I ask that you not switch it to a mixed number. Just leave it that way. Reduce it, but leave it as improper. Okay, next problem. It's a subtraction, so we need a lowest common denominator. Lowest number that 6 and 4 both go into would be 12. 6 times 2 equals 12. 5 times 2 equals 10. 4 times 3 equals 12, and 4 times 3 equals 12, so 3 times 3 is 9. 10 minus 9 is 1/12. Okay? The next one is multiply. With multiply, we just multiply straight. You are allowed to reduce this one if you'd like, but let me show you multiplying straight. You'd have 6 over 15, and then you would divide by 3 on the top and bottom to reduce it. And you would get 2 over 5. Now, if you wanted to reduce before you multiply, you can. Be 3/5 times 2/3. We reduce a 3 there goes once, a 3 there goes once, and we have the 2/5 like that. Either way is acceptable. Okay, 1/2 minus 5/8. Again, you're subtracting and adding, so you need a common denominator. The lowest number 2 and 8 both go into would be 8. You don't need to multiply this 8 by anything. It would just be 8 times 1, 5 times 1. So it'll stay the same. Over here, though, 2 times 4 is 8. So 1 times 4 is 4. 4 minus 5, that's going to be an integer. It's a negative 1 over 8. Okay, to convert a percent to a decimal, it's really important for all purposes that you understand what you're doing. A lot of students will just say you just move the decimal, but you need to understand for purposes of standardized tests, for explaining it to others, anything you need to understand what you're doing here is percent means per 100, as we wrote up above. But that means 4% means 4 per 100. It's important if we have a statistic and it's 4% that you know, that means 4 out of 100 do this. At that point you can divide, you can actually write it in the box and divide it and get the 0.04. Or you can understand that dividing by 100 means simply moving that decimal over 2 places to the left, so it's 0.04. Okay, what I want to see on your paper is the fraction over 100, so that you remember it's dividing by 100, and then you can just go ahead and move the decimal over and give me the decimal answer. I do want to see the fraction midway so that I know that you know you're dividing by 100. And that would be 0.015. Go ahead and pause the video and do this next one, and then you can turn it back on and see the answer. For the last one, perimeter, I have a lot of students who struggle to remember what these mean, or they never knew. Perimeter, I think you all know what rims are. If I run my perimeter around a desk, I go around the outside edge. If I run my pencil around the perimeter of this box, it would be around the outside edge. So perimeter is simply the length of that. You don't need a fancy formula. You can actually figure it out. 4.5 plus 11 plus 4.5 plus 11. Or you can take 2 times 4.5 and 2 times 11. Or you could take 2 times 4.5 plus 11. I get 9 plus 22 equals 31 inches. It is a length that you're just measuring there. Now to find the area happens to be how many squares are covered on the inside. Anytime you're in a room like the math room here, you'll see tiles on the floor with squares, square tiles. That's telling you the area in the room if you count those squares. So in order to find that answer, we simply multiply 4.5 times 11. Don't forget to move your decimal point in, so it would be 49.5 inches squared. Now we get into a little bit of this class work. Let me find my screen there. The top one says to evaluate. There we go. The top one says to evaluate the expression, evaluate using y equals 2. So the first thing I should see you do is plug 2 in for every y value. Please plug in using parentheses. Some of these, the parentheses don't make a difference, but in some they do. So just always get in the habit of using parentheses to plug in. And then you can evaluate whether or not you need the parentheses there to continue. Now in this particular problem, you do need the parentheses, otherwise it would look like 62. So 6 times 2 is 12. That's your final answer. This one you wouldn't really need the parentheses. 8 divided by 2 is 4. This is what we call evaluating in math, is deciding what the final value is. 2 plus 4 is 6. So evaluating is finding the value of an expression. 11 minus 2 is 9. Now realize, because y is a variable, I may ask you another time to do those problems where y is equal to -3, and then you'd get completely different values. That's why we evaluate by plugging in. Okay, given a scenario, write and evaluate expressions. Let's say that we have a scenario where I have a 5-gallon gas can. And gas is costing, let's say, $3.10 a gallon. My question is, how much will it cost to fill it? Well, we would take 5 times 3, 10, to get our answer. It's about $15.50. Now, I might ask you, how much would I get back if I gave the cashier $20? Here you might use an algebra expression, $20 minus m, m being equal to the amount for gas. To solve that expression, I would take 20 minus 1550 and get 450. Okay, down to expressions with exponents, a little bit of vocab. The 3 is called a base. The 4 is called an exponent, just because of its location. And the whole thing is called a power. Okay. If you go down to the table that I have printed there in your notes, I ask you to write these in words. 7 to the first would be 7 to the first power. 5 to the third can be stated as 5 cubed, or 5 to the third power. 1/2 to the third power could be 1/2 cubed. Z to the 5th power is simply Z to the 5th power. Now, to actually calculate those, moving from this side of the table over to the far side, you can see it all on your paper, so you can watch that. The very first one, 7 to the first, is simply 1/7. 5 cubed is actually 5 times 5 times 5. 5 times 5 is 25, times 5 is 125. 1/2 cubed, I know fractions kind of worry you guys, but we just worked on multiplying fractions. Just write them down side by side and just multiply straight. 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8. The next one, z to the 5th power would mean z times z times z times z times z. That's all the more you can do until I give you a value for z. Please make sure in math when you get z's to put a little check through them so we don't mistake them for 2's. Okay. Here we have x to the 3rd, and I want you to evaluate, in other words, find the value when x is 4. So you plug 4 in parentheses, raise it to the 3rd power. This is equal to 4 times 4 times 4. 4 times 4 is 16, times 4 would be 64. K squared would be 2.5 squared. That's 2.5 times 2.5. You should memorize what 25 times 25 is. That would come out being 625, and now move the decimal place over 2 places, and we get 6.25. The last one of those nice fractions, d to the 4th, and d is to be evaluated as 1/3. So we go 1/3 raised to the 4th is equal to 1/3 times 1/3 times 1/3 times 1/3. Now, I go ahead and I multiply straight. 1 times 1 times 1 times 1 is 1. And then I kind of simplified this in a way. I take 3 times 3 is 9, and 3 times 3 is 9, and then I multiplied 9 and 9, which is 81. Okay, that ends the introduction to algebraic thinking for Algebra 1-1.